Hey students, Mr. Hermanson here again. We're going to do video lesson 1.4b part 2. This is where we ended off yesterday. We're on page 9. And remember I was calculating the heartbeats given using my equation that my calculator gave me. And what we said is that if we take 2.2 times 35, which is your breath per minute, plus 22.4, we get 79.24. I'm going to leave that off because I don't think you can have part of a heartbeat. And if we take 2.2 times 100 plus 22.4, we get 242.4. Now, our question here says, do you think your prediction is reasonable? Explain. And one thing about it is this prediction here uses 35 beats per minute, which if you go back and look at our data, 35 is actually inside our data. All right? And when it's inside your data and then you create an equation to predict something from that, you usually get a pretty accurate equation. Now, if you look at the second equation, the second problem I did, we were finding it out for 100 beats per minute, which was outside our data. When that happens, it's a little more risky. And in fact, I'm not sure this makes sense because 242 beats per minute is actually probably more than at least my heart can beat. I'd probably have a heart attack. Anyway, so there's a couple words to describe what I was just talking about. One of those words is in, what's that? Where did that come from? One of those, when it's inside the data, it's called an interpolation. You can write this down. So that means it's inside the data. Making a prediction like that is less risky. But if it's outside the data, that's called an extrapolation. That's when it's outside the data. When you do that, it's a little more risky. So there's some risk involved when you use when you go outside the data and use a number like that with your equation. All right? So there's something else I want you to know about data. Let's move on to this page here. And there's a couple words I want you to know here. When you have a positive slope, and you guys know what that means the line is going like this. When your line goes like that through your data, that shows a positive correlation. If the line of best fit has a negative slope, then you have a negative correlation. And then sometimes there is no relationship at all. You can't really draw a line through it. Okay? So thinking about those, we'll go to the next page here. And I'm going to have you do this. It says, which of the following graphs has a positive, a negative, or no correlation? And then, so go ahead, you guys. Pick out of these four graphs, which ones do you think have a positive? Which one do you think has a negative? And which ones do you think have no correlations? So I'll let you go ahead and do that. You can pause right now and pick your answers. All right, what you should have said is this one has no correlation. There's no pattern at all. This one has a positive correlation because if you were to draw a line through there, it's going from the bottom left to the upper right. This graph 3 has a negative correlation because the data seems as the x increases, the y decreases. And graph 4, you should have said that has a positive correlation also, because as x increases, y generally increases. All right? So, now the next question on this page says, on the graphs that appear...
Please report to the front office. Kayla, please report to the front office.
On the graphs that appear to have a relationship, draw a line of best fit. Okay, I'm going to let you try and do that. Take something straight and draw what you think is a good line to represent that data. Okay, so here's my lines. Your lines might look a little bit different, but basically you should try and make sure there's about the same number of dots above and below the line. Now, number 3 says, which data set appears to have the strongest correlation? That means the dots are the closest to the line. And I think I would pick probably graph 3 for that one. Graph 2 is not too bad either. But basically you're saying, you know, like if you grouped, so this circle represents that group, is that circle tighter around which of these sets of data? So you would see like a more of a narrower circle. So I don't know, graph 2 and graph 3 are about the same maybe. And then the last question says, which data set appears to have an outlier? That might be a new word for you. That means an extreme value. So a value that's out of sync with the rest of them. And you might have noticed right here in graph 4 that there's one little point. Now what you could do if you were trying to come up with an equation is just remove that point because there's something wrong with that data. And that's called an outlier. All right, well that's it for this lesson. We'll talk more about this tomorrow in class.